Hi everyone, this is Keith Meldal. We're doing a little quick module here on wave dispersion. This graph or figure from your book shows us that when we have waves that are in water that is deeper than what's called the wave base, a depth that is equal to half the wavelength, these waves move independently of the bottom of the ocean. They don't feel any friction with the bottom, and we call these deep water waves. When waves move into water that's shallower than the wave base, they start to feel friction with the bottom, they slow down, they get taller, and they eventually break. But we're going to focus here on a process that happens in deep water, a process called dispersion. Dispersion is the separation of different waves by their wavelengths, where faster waves move out ahead and get farther away from slower waves. The next figure shows us a graph that you can see in your book, and it illustrates an important relationship. The graph shows us that longer wavelength waves are faster, and longer wavelength waves also have longer periods, the period being the time in seconds between one crest and the next crest of the wave. So for example, a wave with a 17-second period and a wavelength of about 450 meters is traveling about 26 meters per second, whereas one with a shorter period and a shorter wavelength is going more slowly. That's an important relationship. Faster waves have longer periods and longer wavelengths, okay, than waves that have shorter periods and shorter wavelengths. Remember that when you're doing your assignment after we're done with this module. Now, most waves out at sea in deep water are made by big storms. You can think of a storm as like a wave factory that cranks out a bunch of waves in a short period of time, and those waves travel out from the storm area. If you look at the ocean in a storm, it's a real chaotic mess. There's lots of different waves of different wavelengths all trying to move away from the storm area. But if you let these waves travel away, they'll disperse. They'll separate according to different speeds. And if you go a couple days later and say 1,000 miles away, you'll see a very different ocean. You'll see very uniformly spaced groups of waves of equal wavelength. We call these ocean swells. They all have the same wavelength because they've all been traveling at the same speed. These waves left behind the shorter, slower waves, and maybe even longer, faster waves are ahead of them somewhere else. So the process of dispersion, of separation by speed, forms uniform groups of waves that we call ocean swells. Now I have an analogy for you here. We're on a little pond along the Colorado River where I like to take my boat fishing sometimes. And I want you to imagine that this is actually an ocean basin, and there might be a storm that might happen in this ocean basin at any one place. And I'm going to mimic a storm here by throwing a stone in the water. So there's my storm, and waves are traveling away from the storm. But I want you to notice something interesting. The waves are not all traveling at the same speed. They're separating from one another by their wavelength. I stopped the video here, and you can see that the longer wavelength waves have traveled faster and are getting out ahead of the shorter wavelength waves, which are slower. It's exactly what the graph predicted for us. When these waves eventually come on shore then, they're going to be very uniformly spaced groups of waves that we call swells, the kinds of things that surfers love to ride. Imagine a bunch of people standing around my ocean basin now, throwing rocks in now and then. Each one of those would represent a storm, say across the Pacific Ocean. From each storm, the waves will spread out and disperse according to their speed and wavelength and form uniformly grouped sets of waves called ocean swells, the kinds of things that surfers like to ride, the kinds of things that make life in Southern California a lot of fun. So with that in mind, go back now to the assignment and answer the questions, keeping these ideas in mind.